Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving deep into thread management in the JVM. We're currently in level 3 of our series, focusing on JVM expert topics. Victor, are you ready to unravel the mysteries of thread management?
Absolutely, Sheila. I'm excited to explore this crucial aspect of JVM internals with our listeners. Thread management is at the heart of concurrent programming in Java, and understanding it is essential for writing efficient and robust applications.
Great. Before we jump in, let's remind our listeners that we've previously covered JVM internals, including bytecode, method invocation, and exception handling. Today's topic builds on that foundation. Now, let's start with a quiz question to get everyone thinking. In the Java thread lifecycle, how many distinct states can a thread be in?
Ooh, that's an intriguing question, Sheila. It really makes you think about the different stages a thread goes through during its lifetime. Without giving away the answer, I'd say this question is excellent for highlighting the complexity of thread management. Listeners, keep this question in mind as we discuss thread states throughout the episode.
Absolutely, Victor. Now, let's start with the basics. Can you explain what a thread is in the context of the JVM?
Certainly. In the JVM, a thread is the smallest unit of execution within a Java program. You can think of threads as workers in a factory, each capable of performing tasks independently but sharing the same resources. The JVM is responsible for managing these threads, creating them, scheduling their execution, and eventually terminating them.
That's a helpful analogy. So, how does the JVM create and manage these workers?
Great question. The JVM creates threads in response to application code. When you create a thread object in Java and call its start method, the JVM allocates necessary resources, sets up the thread stack, and prepares it for execution. The JVM then hands off the thread to the operating system's thread scheduler, which decides when and for how long the thread runs.
Interesting. You mentioned the thread stack. How does that relate to the JVM's memory model?
Each thread in the JVM gets its own stack, which is a region of memory used for storing local variables, method parameters, and partial results. This stack is separate from the heap, where objects are stored. This separation is crucial for thread safety and helps prevent interference between threads.
Now that we understand thread creation, can you walk us through the life cycle of a thread?
Certainly, a thread goes through several states during its lifetime. The main states are 1. New, the thread has been created but not yet started. 2. Runnable, the thread is ready to run and waiting for CPU time. 3. Running, the thread is currently executing. 4. Blocked, the thread is waiting for a resource to become available. 5. Waiting, the thread is waiting indefinitely for another thread to perform a particular action. 6. Timed waiting, similar to waiting, but with a specified waiting time. 7. Terminated, the thread has completed execution or been stopped.
Wow, that's quite a few states. How does the JVM manage transitions between these states?
The JVM works closely with the operating system to manage these transitions. For example, when a thread calls the wait method, the JVM puts it in the waiting state and notifies the OS. When another thread calls notify, the JVM moves the waiting thread to the runnable state, making it eligible for execution again.
I see. Now let's transition to another important aspect of thread management. How does the JVM decide which thread to run?
Great question, Sheila. The JVM doesn't actually make those decisions directly. It relies on the operating system's thread scheduler. However, Java does provide a way to influence scheduling through thread priorities. Threads can have priorities from 1, the lowest, to 10, the highest, with 5 being the default. The OS scheduler takes these priorities into account, but it's important to note that thread priorities are just hints, not guarantees.
Interesting. Now, I've heard about something called thread pools. How do they fit into thread management?
Thread pools are a powerful concept in concurrent programming. Instead of creating a new thread for every task, which can be expensive, a thread pool maintains a group of reusable threads. When you submit a task to a thread pool, it's executed by one of the available threads in the pool. This approach improves performance and resource management especially for applications that process many short-lived tasks.
That sounds efficient. Are there different types of thread pools?
Yes, Java's concurrent package provides several types of executor service implementations, which are essentially different kinds of thread pools. For example, fixed thread pool maintains a fixed number of threads, while cached thread pool can grow or shrink based on demand. Each type has its use cases, and choosing the right one depends on your application's needs.
Now, I've heard terms like native threads and green threads. Can you explain the difference?
Absolutely. Native threads are managed by the operating system and can run on multiple CPU cores. This is what modern JVMs use. Green threads, on the other hand, are managed entirely by the JVM and run in a single OS thread. They were used in early Java versions, but have been phased out due to limitations in utilizing multi-core processors.
Interesting historical context. One last question. What's the difference between daemon and user threads?
Great question. User threads are the default type and are what we've been discussing so far. Daemon threads, on the other hand, are background threads that don't prevent the JVM from exiting when all user threads finish. They're typically used for tasks like garbage collection or servicing user threads.
Thank you, Victor. Now, let's reveal the answer to our quiz question. How many distinct states can a Java thread be in?
The answer is 6 states. These are new, runnable, blocked, waiting, timed waiting, and terminated. Note that running is considered part of the runnable state in the official Java specification.
Excellent. To wrap up, let's summarize the key points we've covered. 1. Threads are the smallest unit of execution in the JVM. 2. The JVM creates and manages threads in cooperation with the operating system. 3. Threads go through various states in their lifecycle. 4. Thread scheduling is handled by the OS, with input from Java's priority system. 5. Thread pools offer an efficient way to manage threads for multiple tasks. 6. Modern JVMs use native threads, which can utilize multiple CPU cores. 7. Daemon threads run in the background and don't prevent JVM shutdown. In our next episode, we'll be diving into synchronization primitives, so stay tuned. If you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue producing this content. Thanks for listening.